key topic that I want you people to understand is moment of a force, torque. Now, this is a very important topic, and this children are very confused up to 12th. In IIT also people feel rotation, torque, this whole thing इसमें ऐसे रहता है बच्चों को कि घूम जाता है दिमाग. नहीं है ऐसा कुछ भी. It's as simple as linear motion, provided you understand it with conceptual clarity. And I just want you people to pay attention and you will find things easy. Ready? Just see this. If suppose there is a body, this is my origin, x-axis and y-axis. In this plane, I have a point mass. That point mass is here. Please pay attention. And this point mass is connected to the origin like this through a rod. This is a massless rod. This blue color rod is a massless rod and it has some length L, suppose. And this is a point mass which has mass M, and I am going to apply some force on it. If I apply a force on it, and this is a rigid rod which is connected to the origin, and this rod is, if I apply a force along the length of this rod, what will happen to this point mass? Please tell me. Will it move? Will it accelerate?
No.
It will not. If it was only a point mass in space, and had I applied the same force on it, the same force would have given it an acceleration, and I would have said, if m is the mass, force would have been mass into acceleration if a was the acceleration of this body. But right now, I told you that there is a rod which is connected to the origin, और यहाँ पे ये rod इस point mass से connected है, and this is a massless rod, and this point mass is connected to it, and I am applying a force along the length of the rod. Along the length of the rod. What will happen to the point mass? Will it accelerate or not? Yes or no? Quickly. Will this point mass accelerate or not? The rod is fixed. The rod is fixed to the origin here. The other end.
No.
The rod can rotate. But
Sir, it won't move, sir. So since it is attached.
good. You can treat it as a string. Okay. Instead of a rigid rod, treat it as a string of length L. This is a string, green color string. Now, it will not move. It will not elongate. String is inextensible and it will not move at all. This force will have no effect. Now, the moment I apply this force at some angle, this force is acting at an angle to this direction. Now, this force will have two components. One component will be along this, which will be how much? If the suppose this force is F0 cos theta, and the perpendicular component will be
F sin theta.
F not sin theta.
we learned this in vectors. Yes, how to resolve a force, how to resolve a vector into two mutually perpendicular directions. Now, F cos theta will not cause any kind of acceleration, neither translational nor rotational. This is not causing any effect on the length of the string is inextensible. There will be tension, but it will not move at all. But this force is going to have an effect. And what is that effect? What will it do? How will this particle move?
Turn it, sir. Rotating.
So this particle will start moving in a circle and it will go along the tangent like this. And if this force is accordingly shifting its direction so that the component along the tangent remains F0 sin theta, it will move in a circle because the length of the string is constant. So only this force at this instant, only this force will have its effect, and that effect will be rotational effect, as if it is moving in a circle of radius L, and at this instant, this rotational effect of this force is going to be called torque. And how much is that rotational effect? By this force is going to make it accelerate along the tangential direction. Along the tangential direction. And let that acceleration be AT. So I can say in this direction there is only one force. In this direction there was net force was 0. This force was F cos theta. There was some tension. Net force was 0, so it was not accelerating in radial direction along the radius. But along the tangent, there is only one force, which is F naught sine theta. And net force is equal to mass into acceleration. This will give it a tangential acceleration. And this will lead to a rotational effect, rotational motion. So you got a rough idea about a force trying to rotate and not able to make it move in a direction which is radial. Now, another example I'll give you to make you understand what is torque, the rotational effect of a force. If I want to define the torque in terms of layman's language, all of you please pay attention. Torque is the rotational effect of a force. That is called torque. If a force is just making, for example, अगर मैं दरवाजे पे कोई फोर्स लगाऊं, क्या दरवाजा एक्सेलेरेट करना शुरू कर देगा अपनी जगह से? नहीं, इट विल रोटेट ओनली अबाउट इट्स हिंज. सो दरवाजे पे आप कोई भी फोर्स लगाएंगे तो वो रोटेशनल इफेक्ट ऑन द डोर प्रोवाइड करेगी, एंड दैट रोटेशनल इफेक्ट ऑफ अ फोर्स इज कॉल्ड टॉर्क. सो दिस इज लाइक अ लेमन्स लैंग्वेज. Now we'll come to a proper scientific expression of torque. Now, torque is also defined as, if suppose there is a force F acting, the simplest kiddish definition, F naught is the force, and there is a point which is at a distance D. This is a point which is at a perpendicular distance from it. D perpendicular. This force will exert a torque about point P. And that torque will be F naught into the force into arm length. This is called arm length. The perpendicular distance from the point about which we are calculating the torque. So this point, say you drop a perpendicular distance on this line of action of force, and this is called arm length, lever length or arm length. So torque is also equal to force into perpendicular distance. And ये लिख लीजिए आप पहले. This is called torque mathematically. I am writing a very kiddish definition right now. First time introduction to torque because you are in 10th. अभी हम इसकी proper vector representation पे भी आएंगे. But first I want you to understand what is happening. Now see this. If suppose there is a rod of, this is a rod which is hinged here, and this rod, door, whatever you, any kind of thing, and you apply a force on it in this direction, F naught. This force will have a turning effect on it, and it will try to rotate it like this, about this axis of rotation, hinge. And that rotational effect of a force will be torque, and torque will be force into arm length, force into perpendicular distance from the point of application, from the point about which we are calculating the torque, जिसके about rotation हो रहा है. Now, if you have understood this, this is like, this was layman's language, बिल्कुल, कि एक बिल्कुल illiterate आदमी को layman's definition. This is junior school, kiddish, kids definition, whatever you call it. I'm just making you register in your mind that this is the definition, there is nothing wrong in it, but this is like a very bachcho wali definition, simple, so that children understand it. So here I want you to register one more thing. So if this force will act on this rod, how will this rod rotate? This red color pencil, how will it rotate? Will it rotate clockwise or will it rotate anti-clockwise? All of you please try to answer.
Clockwise.
Clockwise.
Lovely. Everyone is attentive. I can see that. Now it will have a clockwise rotational effect on this rod. Now clockwise is a very debatable. Clockwise and anti-clockwise was eliminated from the picture. Science ne, and I'll tell you why. If, please tell me, this pen is rotating clockwise or anti-clockwise? Tell me fast.
Anti-clockwise.
Anti-clockwise.
For you, it is anti-clockwise, and for me, if I see it from the other side, from my side, this is clockwise for me. And for you, from that side, it is anti-clockwise. So clockwise and anti-clockwise becomes a debatable way of looking at angular motion. कि clockwise घूम रहा है anti-clockwise, आप पंखे के इधर खड़े हो जाइए एक आदमी और एक उस साइड खड़े हो जाइए, both will tell a different thing. साइकिल के टायर को घुमाइए, एक फ्रेंड को लेफ्ट साइड इधर खड़ा कर लीजिए, एक को उधर खड़ा कर लीजिए, एक बोलेगा क्लॉकवाइज घूम रहा है और दूसरा बोलेगा ये तो एंटी क्लॉकवाइज घूम रहा है. सो क्लॉकवाइज और एंटी क्लॉकवाइज बिकेम डिबेटेबल. We wanted to define the direction. Same rotation can be said clockwise from one side of the coin, and from the other side you will find the same pen. For me, it is having a clockwise rotation. Can you imagine this? Can you imagine what I'm trying to say? From my side, my perspective, from your side, if you are observing it, it is rotating anti-clockwise. But for me, from my side, just see this. For me, the rotation is this, and this is clockwise from my side. So the moment we are on the opposite side of the plane, clockwise, anti-clockwise, meaningless. So the scientific community found a way of representing this direction कि भाई ये राइट तरीका नहीं है, क्लॉकवाइज एंटी क्लॉकवाइज. सो इवन दो हियर बच्चों वाली डेफिनेशन में आई कैन से इट इज क्लॉकवाइज, सो यू कुड हैव रिटन इट एज क्लॉकवाइज, और यू कुड हैव रिटन इट एज, अब हम करेक्ट डायरेक्शन में आएंगे. अब इस क्लॉकवाइज और एंटी क्लॉकवाइज की कहानी समझ लीजिए. सो इफ आई से सपोज राइट हैंड थंब रूल, प्लीज राइट हैंड स्क्रू रूल, इफ यू कर्ल योर फिंगर्स in the direction of the force, just see this, keep your thumb perpendicular to the plane of force and this distance, and keep it perpendicular to the plane thumb, and now curl your fingers in the direction of force in which the force is. Just see this, clockwise rotate करता है. तो जब ऐसे मैं अपनी fingers को rotate करूंगा तो मेरा thumb is going into the plane, and that is the direction which I should represent, and let that direction be n cap. N cap, sorry, n cap. N cap is a unit vector into the plane. Now अगर into the plane आपको बोलना है तो you will mark that direction like this, as if a arrow has gone into the plane. और हम यहां से देख रहे हैं पीछे से एरो अंदर घुस गया है प्लेन के अंदर. और अगर आउटसाइड द प्लेन वाली डायरेक्शन दिखानी है, मैं आपको मैग्नीफाई करके दिखा रहा हूं. तो इमेजिन इट एज अ सर्कल विद अ डॉट. This direction is outside the plane. This direction is inside the plane. Inside the plane, out of the plane. Are you able to understand what we are trying to say? Now,
Yes.
if I say clockwise, this force will have a clockwise rotation. We now board is on the same side for both of us. You and me are on the same side of this board. If I would have been on the other side, I would have had the same thing which is clockwise for both of us. You as well as me would have been anti-clockwise for a person who's seeing the whole motion from other side. Anyways, now this clockwise thing, rotation, the thumb will go into the plane. If I rotate this in the direction, so this has a direction like this of rotation, and this rotation is clockwise, and if I hold my fingers in clockwise curl, so my thumb will point into the board, and that is the direction of n cap. Torque. अब ये भी आपको थोड़ा सा लग रहा है कि भाई ये क्या कर रहे हैं, डायरेक्शन कैसे लिखें. देयर इज अ वेरी प्रॉपर सिस्टमैटिक वे ऑफ डिफाइनिंग टॉर्क एंड वी विल कम टू दैट. So for 10th class students, most probably in your textbooks, you will have this definition. Torque is equal to force into perpendicular distance, and direction is clockwise or anti-clockwise, or you will have direction maximum, they will go up to this level. Okay, clockwise can be into the plane or outside the plane, and this is a unit vector in its direction. और ये आपकी torque की definition हो गई. Now, if we want to understand torque in literally perfect terms, the best definition, and we want to do all the questions of physics and never get stuck with the sense of direction or magnitude or definition perfect, this is the perfect definition. So if you have a force F naught and you want to find the rotational effect of this force about any point P, here is that point. So the perfect definition is on the line of force. This is called line of force, line along which that force is acting. Choose any point and join this point to that point. Let this vector be R. Then R cross F, torque is given by R cross F. Please note it down. This is the correct definition. Cross product, we got introduced when we were doing vectors, and when you will properly cross product, we know this will be what? Torque will be equal to R cross F will be magnitude of R, magnitude of F into sine theta. And this will be, there will be a vector. R cross F is a vector. And what is the direction of that vector? We'll find out. Let's see. Abhi maine n cap likh liya. Now, how do I find angle between the two vectors? Who will tell me? How do I find what is the angle between R and F? Is this
By
the
putting
angle
the tails
between,
together.
is this the angle between R and F?
No.
Yes.
No.
No, sir.
No.
180 minus that.
1 minute. How many of you understand this is not the angle between the two vectors? And to find the angle between the two vectors, we have to bring their tails together. How many of you understand that? Please give me a thumbs up. Yeah, Inesh, I'm explaining this. Try to understand the perfect definition. And with this definition, you will get the previous two automatically. So be attentive, pay attention. Now, great. Lot of people are giving me a thumbs up, but I still want everyone to be alert because this is a very crucial thing that I'm teaching, and we'll know its simplified form also. But the perfect form is this. This will continue up to 12th also. This will be used in IIT also. And this will be used in first year IIT also. This definition of torque, of a force. And it will never fail you in direction, it will never fail you in magnitude. Others are simpler definitions, simpler versions of that definition. And for 10th kids, they teach you force into arm length, and that's it. Because you are not supposed to be doing too complicated questions. But why not? Let's understand the thing in perfect perspective. You will remember it and we'll learn its simplified version also. See this. Now, first thing I wanted you to register is R vector and F vector. Their tails have to be brought together to find the angle between them. So to get that angle, I need to shift one of the vectors. So I shift R vector parallel to itself. And suppose this is R. Same direction, same length. थोड़ा सा diagram उतना perfect नहीं बना है. Straight line. And now this is R. I brought their tails together. Suppose this is R. Length same. I just shifted this vector from here to here. Now, will this angle be the angle between the two vectors? Yes or no?
Yes.
Just
Yes,
say
Yes,
yes
sir.
or no.
Yes, sir.
Yes.
Perfect. Perfect. So we found the angle between the two vectors is this. This is the perfect angle. Great. And I should remove this angle because this is not the angle between the two vectors. I am removing this. Good. Now, if I have to find R cross F, I have to place their tails together and rotate R. Quick, tell me. R towards F. Cross product I taught you when I was teaching you vectors. A cross B will be, you have to turn A towards B through the smaller angle. So will I be turning it like this?
Yes, sir.
Yes.
Yes, sir.
R cross F. I am going to turn R towards F. And when I'm curling my fingers from R to F, the thumb is pointing into the plane of the board, yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Great. So I'm marking that R cross F comes out to be into the plane and this will be equal to this much. So I got the direction of n cap. N cap is into the plane. Okay. If I now simplify this, see this. I drop a perpendicular from here on this line of velocity, perpendicular. Now, if this is theta, this is 180 minus theta. Yes or no?
Yes.
Yes.
Because I just took vector r ahead, just to shifted it parallel to itself and took it ahead to bring their tails together. So I know if this is theta, this is 180 minus theta. If this is 180 minus theta, can you tell me in this triangle, triangle A, B, C, P, A, B, P, can I say R? Acha, first tell me sine 180 minus theta is what?
Sine theta.
Sin theta.
Exactly. So when you will learn trigonometry, you will learn this quadrant changing formula. You will know sine 180 minus theta is same as sine theta. This knowledge you need. So I'm assuming in 10th or 11th, when you learn trigonometric ratios and identities, you will know it very clearly that sine 180 minus theta is same as sine theta.
We
Okay.
have done this
So-
in maths.
Perfect, perfect. If you have done this much, then my life is easy. What is sine 180 minus theta in this
Sir,
triangle ABP?
Sir, I have a doubt.
First, let me finish this, then you ask your doubt. So sine of 180 minus theta, yeah, phi.
So it's
Sine, if
PB by
I
R.
call it phi, sine phi will be what?
PB by R.
PB by R, correct, will be equal to PB by R. So can I say PB, which is the perpendicular distance? PB is what? The perpendicular distance. Yes or no? From the point on the line of action of force. This is the perpendicular distance. So PB is perpendicular distance is equal to R sine 180 minus theta, which is same as R sine theta. I am going to use it here. R into sine theta can be written as what? R into sine theta can be written as what? D perpendicular. So I am getting torque is equal to F naught into perpendicular distance into, are you getting it? N cap. This is the same definition which they teach you. Force into arm length. So I taught you this definition is the best way to understand torque. And when you will be strong in vectors chapter, you will understand it in vector form. You will never get any wrong answers. So understanding it gives you the direction and magnitude both. Once you use this, simplify it, it finally boils down to this same equation which we were learning. And this is called torque. Torque is force into arm length, force into perpendicular distance from the point about which we are finding the torque, and it has a direction clockwise or anti-clockwise. We, instead of preferring it to call it anti-clockwise or clockwise, we will give it a unit vector in a particular direction, and that is into the plane or outside the plane. R cross F will be a vector which will be perpendicular to the plane of both. So if R is in the plane of the board, F is in the plane of the board, R cross F has to be perpendicular to the plane of the board. So A cross B, if A and B are any vectors, A cross B will always be a vector which is perpendicular to the plane of A and B. Perpendicular to AB. Anyways, now this is a proper definition of torque. I want all of you to note down this. And now I'll physically explain what is happening. So ये तो मैंने आपको mathematical definition बताई of torque. अब physical situation पे आता है कि what
I
is...
have a doubt.
Sir, I have a doubt as well.
Please ask your doubts. Yes, it's a new
Sir,
topic introduced. Huh.
isn't sine 180 minus theta equal to cos theta?
Sine 180 minus theta is
No,
sine
that's
theta.
90 minus theta.
Cos theta.
No, it is not cos theta. It is sine theta. Go and check your identities. You will know it without any doubt. Cool.
Sir, how did you get the final formula after d1 is equal to mod r sine theta?
So we saw in this triangle ABP, ABP, in this triangle, we found that sine theta, sine phi, sine of this angle can be written as opposite side upon hypotenuse. Opposite side is D perpendicular. This is D perpendicular upon hypotenuse is R. I will take it this side. So I'll get D perpendicular is equal to sine 180 minus theta is sine theta. And R got multiplied here. So R sine theta. R sine theta can be written as R sine theta can be written as D perpendicular. Here, I got that from here. And we get the same basic result, force into arm length. That's it. Okay. In 10th, if
So
you are
d1 is
able
the
to...
length of the rod.
Huh?
So d1 is the length of the rod.
Arm length. It is not necessarily always going to be a rod. Suppose there is a force, F naught, and there is no rod. There is a point. Will this force have a rotational effect about this point? Yes, it will. Whether there is a rod or a body or not, it has a rotating effect. And that torque will be there irrespective even if there is no rod. Are you getting what I'm saying? Drop a perpendicular, force into perpendicular distance. This will be the torque, rotational effect of this force about this point P. Please understand this. So likhiye. So here it is very important. Where is your axis of rotation or point of rotation? आप किसके point P के about अगर rotational effect of this force निकाल रहे हैं तो you will write torque about point P is equal to force into arm length. Arm length is the perpendicular from that point on the line of action of force. And it will have a direction which should be always given by R cross F. So if I assume this to be R, जरूरी नहीं है कहीं और लूं, मैं इसी को R ले सकता हूं. A vector joining this point on the line of force anywhere. So R cross F, shift R here, F is in this direction, R is in this direction, R cross F is into the plane. So the torque about this point is this way, यानी कि clockwise rotation. So this force has a clockwise rotating effect, and that clockwise is clockwise from our side, and it is that the best way to represent that is a vector into the plane. A vector perpendicular to the plane into the directed into the board. Now, so please understand this basic definition. बिल्कुल बेसिक है ये, और The best way
सर वो
to
क्रॉस
write
से डॉट
torque.
कैसे हो गया?
हाँ, ये perfect definition है. This
Look the
is,
direction out now.
please quick, see this. If this force is acting in this direction, its rotational effect about this point will be clockwise. This way, it will have a rotating effect. अगर कोई भी चीज कनेक्टेड होगी तो वो उसको ऐसे रोटेट करने की कोशिश करेगी, ऐसे. This force. It will have a rotational effect which is clockwise. And when we say clockwise, I want to avoid clockwise and anti-clockwise. I explain to you why. And that should be represented in the form of a unit vector into the plane of the board like this. Anyways, अभी आता है. ये थोड़ा सा आप लोगों के लिए वेक्टर फॉर्म में टफ लग रहा होगा, but this definition is easier version. And this is like the perfect definition. But that's it. These three things I want you people to understand. Magnitude is force into arm length. If you want to write it in the form of a vector, torque vector. Sorry, I should have written it as a vector, not this bar. Torque vector about point P is equal to force magnitude into perpendicular distance magnitude.
सर वो एफ नॉट है या वो एफ डॉट डी वन है?
F naught. F naught.
So in
Huh.
the formula below, how do you know the direction of R? Like in the previous slide,
R has to be from the point जिसके अबाउट हम टॉर्क निकाल रहे हैं, वहां से शुरू करके एनी वेक्टर joining the force on the line of force anywhere. So
okay,
this is R. This direction is R.
Sir?
This vector.
Sir, I
Now,
have a doubt.
sure.
Sir,
Sure.
sin 180 minus theta तो minus sin theta होगा ना?
Sin 180 minus theta is sin theta. If you remember, आप सब बच्चों की ट्रिग्नोमेट्री A S T C sin 180 minus theta किस क्वाड्रेंट में पड़ेगा? आप बताइए. यहाँ पे होगा.
ए और सी गलत लिखा है सर.
भाई 180 यहाँ से यहाँ तक है, उसमें से थीटा सब्ट्रैक्ट कर दो तो 180 माइनस थीटा. यहाँ पे साइन इज पॉजिटिव, ऑल आर पॉजिटिव, सो साइन विल बी नॉट नेगेटिव, सो इट इज साइन थीटा ओनली. बेटा आप अपनी ट्रिग्नोमेट्री मुझसे मत पढ़ो, मुझे फिजिक्स पे फोकस करने दो. अटेंटिव नाउ. दिस इज, हाँ प्लीज फील फ्री.
Sir, does that mean that if we shift F naught, then the torque will change?
If we change F naught magnitude, torque will change.
No.
If we change the arm length, if we change the point, what are you saying?
But sir, if we change the position of the vector,
No. If you take it here on the line of force, anywhere,
no sir.
हमने वही तो लिया था इससे पहले. देखिए, we took it here somewhere and it came out to be F naught into perpendicular distance only. That R sin theta component will come out to be this. आप R कहीं पे भी ले लो, on the line of action of force anywhere. Good, you observe this.
But sir, F की position हम change नहीं कर सकते ना?
भाई F की पोजीशन हम चेंज नहीं करेंगे, जो एक्चुअल में लग रही है we will take that. Clockwise and anti-clockwise movements, please try to understand. If suppose there is a rod, please see this. This is of mass m, length L. ठीक है? M mass, L length. Suppose this rod is hanging here with a string. This rod is hanging here also with a string. ऐसे. If I ask you find the tension in the strings, so the rod has its mass mg acting here. Free body diagram. Tension will be acting in the strings. Suppose this is T1. Suppose this is T2. They are different strings, so I mark different tension. Now, these are the three forces. These three forces will have net force. This rod is in equilibrium. I want you to make you understand how torque acts. So when this is in equilibrium, net force is 0. So I'll make a free body diagram of this rod. I will have these three forces, mg downwards on the rod, tension upwards, T1, T2 upwards. What will be the force equation I will write? Net force downwards mg minus T1 minus T2 is equal to mass into acceleration. Acceleration is 0. It is at rest, equilibrium. Net force is 0. Now, if there is equilibrium, net torque is also 0. It is not rotating also. Now let's find out the torque about any of the point. Suppose I want to find the net torque about this point. This point is P, this point is Q, and this is center of mass, C. If I want to find the torque about of all the forces about this point, this is my point. अभी हम torque निकालना सीखे हैं about a point. Please go back and see the definition. What was the torque of a force? Force into perpendicular distance, arm length. Force into perpendicular distance. So let's use the same definition and tell me there are three forces acting on this rod. One is T2, which is passing through this only. What is the perpendicular distance of this point from the line of action of this force?
0.
0. So the torque due to T2 about this point P is 0. We are finding torque about P. Net torque. ठीक है? So इसकी तो 0 हो गई. mg की टॉर्क बताइए, रोटेशनल कितना टॉर्क लगा रहा है वो. दिस फोर्स, ये तो फोर्स हो गई. परपेंडिकुलर डिस्टेंस कितना है इस पॉइंट से ऑन द लाइन ऑफ फोर्स? क्विक, हाउ मच इज द परपेंडिकुलर डिस्टेंस? If L is the length, so this distance will be L by 2. Center of mass is at the center. So it will be L by 2. So we will say mg into L by 2, force into perpendicular distance. Tell me, this force will be trying to rotate it in clockwise or anti-clockwise direction? Quick.
Anti-clock.
This direction. This direction is clockwise.
Clockwise.
now.
And if I want to write it in the vector form, so if I hold my fingers along the curl, my thumb is pointing towards the board, right or not? How's my thumb pointing if I curl my fingers in the direction of this clockwise direction? My thumb is pointing towards the board. So I will say into the plane of the board. So clockwise बोल लीजिए. चलिए अभी हम clockwise को positive ले लेते हैं. So this is clockwise moment. Now please tell me, torque due to T1 will be clockwise or anti-clockwise? पहले तो ये बता दीजिए.
Anti-clock.
Anti-clockwise. And this force is T1 upwards. This force T1. And what is the arm length? What is the
L.
distance from L?
L.
So the torque due to this will be minus y, because clockwise I chose to be positive. So anti-clockwise, this was positive. So anti-clockwise will be negative. Minus
LT1.
T1 into L. Yes. And net torque should be 0 because the body is in equilibrium. It is not rotating at all. The rod was hanging on the strings and is in equilibrium. It is told already. So the net torque should be 0. Now, from here, I get the value of T1. What is T1? T1 is equal to
mg by 2.
mg by 2. And what is T2? Put the value here. You will get T2 is also mg by 2. So, the strings were dividing half the load on each of them. So here it was T by 2. Here it was T by 2, mg by 2. And here it was mg by 2 upwards. and net force was नीचे center of mass की mg. So net force was 0, net torque is 0, and now this was like the simplest. Now if I give you a better situation, better question, and I ask you to find the values, you will face some challenges. So let me consider another case of a rod, same rod, m mass, l length, and now again it is hanging with two strings like this from the roof. ऐसे m mass, l length. Now there is a catch. Now there is another mass of 2m mass which is at a distance of l by 4. This is a point mass. This is point mass. Its mass is 2m, twice the mass of rod. It is kept here and still they are in equilibrium. They are identical strings. Find the tension in the both. Now, have you understood the question? So now there is mg also. Rod's center of mass has mg force. There is a point mass which is
So we take
kept
torque
on this.
upon which point?
You have to tell me what is the tension in each string. You have to tell me what is the tension in each string. T1 and T2. कोशिश करिए. Try. So there is a point mass which is added to the rod here and it is sticking to the rod. अब थोड़ा टेंशन्स में इक्वलिटी नहीं रहेगी. पहले तो सिमेट्रिक डिस्ट्रीब्यूशन था मास का, सेम टेंशन आ गई. अब T1 और T2 डिफरेंट होंगी. यू हैव टू फाइंड आउट व्हाट इज T1, व्हाट इज T2, टेंशन फोर्स कितनी कितनी
सर वो
होगी.
बीच में ग्रीन पॉइंट क्या है?
एंड द
Center
बॉडी
of
इज इन
mass.
इक्विलिब्रियम. एवरीथिंग इज इन इक्विलिब्रियम. हाँ, यू वर आस्किंग समथिंग, प्लीज आस्क.
सर जो ग्रीन पॉइंट है वो सेंटर ऑफ मास है.
ये ग्रीन पॉइंट, यस, दिस इज सेंटर ऑफ मास. Mass of the rod can be assumed to be here. So mg is acting here and 2mg is acting here. 2m is a point mass here. Now, अब क्या करेंगे बताइए. Net force is equal to mass into acceleration. Should I do it or you want to try? You want to try or should I do it? Quick.
Sir, can you let us try for a few minutes?
So let us.
ठीक है. Give it a try. Give it a try. This is the last question of the day and I want everyone to give it a try. And this is beyond your 10th level. Your story gets over at force into arm length for 10th. But ये सब जो हम कर रहे हैं, ये फ्यूचर और कॉन्सेप्चुअल लेवल पे समझने में कोई भी बुराई नहीं है. It will help you in every exam in future. Be it your boards, be it your competitive exams, everywhere. So I want you people to give it a try. So if it is in equilibrium, net force has to be 0, net torque has to be 0. Net force 0 means what? The equation will be T. I'll make a free body diagram. This is the free body diagram. T1, T2, M2G, 2mg, mg. So net upward force T1 plus T2 minus 3mg नीचे की तरफ is equal to 0. Net force is equal to mass into acceleration. एक फोर्स दूसरी फोर्स माइनस mg माइनस 2mg यानी कि माइनस 3mg. नेट फोर्स इज इक्वल टू 0. इक्विलिब्रियम की कंडीशन है. They are not accelerating. The rod is not falling down, going up. So acceleration is 0. Net torque is 0. Now net force is 0. ये जो हमने किया है. This is equilibrium in terms of forces. Now rotational equilibrium, the moment of forces, यानी कि torque. Net torque should also be 0. Net torque will be 0 if, which point you want to choose this time for finding torque? Quick. Which point?
T2.
You can choose any point because
सर
net
दोनों
torque.
करना पड़ेगा ना, because दोनों T निकलना है.
So
You
T1
can
is
If we find
5
any
by
T,
4
then
and
we can
T2
find
is
the other
7
T.
by 4.
suppose I
So we
choose
can do
this
P
point.
first and then find T2.
This time I'm choosing this as P, this as Q, and I'm going to choose this point. मेरा मन कर रहा है. I could have chosen this point. I could have chosen this. Any point के about torque is 0. Let's see. Net torque about P.
T1 is 5/4 and T2 is 7/4.
Don't tell me the values. I know you might be right, but हमें करना है ना. So 10 torque due to this
So we
will
write
be
it
how
as
much about
mg
this
L
point?
by 2 plus
What is the
2
torque
mg
due
L
to
by
T2? About this point,
0.
everyone respond.
0.
0, because force into T2 into arm length. What is the distance of this force from this point? It is already passing through this point. 0. Good. Now,
Sir,
next,
can you explain how is it 0?
how it is 0? Line of action of the force is this. This is the line of action of this force, T2. And we have learnt if there is any force जिसकी वजह से टॉर्क निकालनी है अबाउट एनी पॉइंट, आप उस पॉइंट से परपेंडिकुलर डिस्टेंस रखते हैं. फोर्स इनटू परपेंडिकुलर डिस्टेंस. अगर वो पॉइंट इसी पे लाई कर जाए जिसके अबाउट टॉर्क निकाल रहे हैं, तो परपेंडिकुलर डिस्टेंस क्या हो गया पी का. अगर पी यहीं पे हो गया, पी यहां ना होके यहां है, इसी के अबाउट टॉर्क निकाल रहे हैं, तो व्हाट विल बी द परपेंडिकुलर डिस्टेंस ऑफ दिस पॉइंट फ्रॉम दिस फोर्स? 0.
0.
That's why the torque of T2 is 0. Got it? Got it?
Sir,
No. Hmm?
M is the mass of the rod.
M is the mass of the rod. 2m is a extra additional mass which is kept here at a distance L by 4. I want to find the net torque about all the four forces.
So, sir,
One,
the equation of that you have written, it's only for the rod.
we are finding the net torque of or acting on the rod. Yes,
No, the
acting on the
force equation.
force into perpendicular distance. T2 की वजह से 0 हो गई. अब 2mg की वजह से बताइए कितनी होगी? क्लॉकवाइज या एंटी क्लॉकवाइज? किधर रोटेट कर रहा है ये इस पॉइंट के अबाउट? ऐसे रोटेट कर रहा है, एंटी क्लॉकवाइज. ठीक है, एंटी क्लॉकवाइज रोटेट कर रहा है, तो मैं क्या लिखूंगा? 2mg फोर्स इज दिस 2mg इनटू आर्म लेंथ कितना है? क्विक
L by 4.
क्लॉकवाइज या एंटी क्लॉकवाइज, किसको पॉजिटिव लेना चाहते हैं आप? मैंने एंटी क्लॉकवाइज को पॉजिटिव लिख दिया है ऑलरेडी ये. ठीक है, दिस इज एंटी क्लॉकवाइज. यस और नो? ऐसे घुमा रहा है ना,
Yes.
coming out of the plane. Thumb is coming out of the plane. So if you curl your fingers in this direction, force की direction में, the thumb will come out of the plane. So this is the direction. So anyways, anti-clockwise लिख दिया, anti-clockwise को positive ले लिया. ये कैसे rotate कराएगा? Clockwise या anti-clockwise? Quick.
Anti-clockwise.
Anti-clockwise. तो इसको भी positive लिखेंगे. mg into what is the arm length? Quick. ये arm length कितना है?
L by 2.
परफेक्ट. अब ये जो फोर्स है ये कैसे घुमा रहा है? क्लॉकवाइज या एंटी क्लॉकवाइज अबाउट दिस पॉइंट?
Clockwise.
क्लॉकवाइज. क्लॉकवाइज को नेगेटिव लिख देता है. T1 into L. आर्म लेंथ इज L. यहां से आर्म लेंथ इज L.
क्लॉकवाइज कैसे होगा?
देखो बेटा, ये इसे इस पॉइंट के अबाउट एंटी क्लॉकवाइज घुमा रहा है, ये भी इसे एंटी क्लॉकवाइज घुमाने की कोशिश कर रहा है. बट वो जो फोर्स है ऊपर लग रही है T1, वो इसे यूं घुमाने की कोशिश कर रही है. ये दोनों तो इधर इधर घुमा रहे हैं एंटी क्लॉकवाइज, और वो T1 जो है वो इसे ऊपर यूं घुमाने की कोशिश कर रही है. सो इट इज ये एंटी क्लॉकवाइज, ये एंटी क्लॉकवाइज, ये
Sir?
क्लॉकवाइज. हाँ,
सर आपने mg का टॉर्क निकालने के लिए रेफरेंस q को लिया कि p को लिया?
we are finding torque about a point. Torque is always found about a point. तो मैंने ये पॉइंट लिया जिसके अबाउट हम टॉर्क निकाल रहे हैं, P. सो सारी फोर्सेस का इसी के अबाउट निकाल रहे हैं हम. इस फोर्स का 0 आया, इस फोर्स का आया 2mg इंटू आर्म
टेंशन
लेंथ.
डाउनवर्ड्स कैसे एक्ट कर रहा है?
क्या चीज? टेंशन.
हाँ, T2.
टेंशन डाउनवर्ड नहीं एक्ट कर रहा है, टेंशन तो अपवर्ड ही एक्ट कर रहा है. दोनों, ये वाला इस पे ऊपर, ये वाला इस पे ऊपर. लेकिन टेंशन के लिए मैंने आपको सिखाया 2 एरोज टुवर्ड्स ईच अदर. छत को नीचे खींच रही है रस्सी और रॉड को ऊपर खींच रही है, तो वी विल ऑलवेज शो टू एरोज। अगर मुझे रॉड का फ्री बॉडी बनाना है तो यहां से बस खत्म हो गई बात कि रॉड पे ऊपर लग रही है टेंशन, रॉड पे ऊपर लग रही है टेंशन, ठीक है, और
तो फिर
छत पे
T2
नीचे खींच
से
रही है छत को रस्सी।
तो फिर
हाँ,
T2 उसे एंटी क्लॉकवाइज कैसे घुमा रहा है?
ओके, लेट्स सी। एक रॉड ले लेते हैं ये रही, और यहां पे उस रस्सी को थोड़ा खींच के यहां ले आया हूं पास, और ये रस्सी ऊपर फोर्स लगा रही है ऊपर, तो ये इसे कैसे रोटेट करना चाह रही है, यूं ना, एंड दिस इज व्हाट, क्लॉकवाइज,
यस।
ठीक है। और ये 2mg कैसे लगाना चाह रहा है इस पे फोर्स, टॉर्क, क्लॉक एंटी क्लॉकवाइज। 2mg तो इसे एंटी क्लॉकवाइज घुमा रहा है, mg एंटी क्लॉकवाइज घुमा रहा है, और वो क्लॉकवाइज घुमा रहा है, बस दैट्स इट। एंटी क्लॉकवाइज को पॉजिटिव ले लिया, ये पॉजिटिव और इसको माइनस लिख दिया, क्लॉकवाइज वाले को पॉजिटिव लिख दिया। T1 इंटू आर्म लेंथ इज ये फोर्स इंटू परपेंडिकुलर डिस्टेंस फ्रॉम दिस पॉइंट इज
सर
L।
सर आपने T2 को पॉजिटिव क्यों लिखा? क्लॉकवाइज
हाँ
होना चाहिए ना T2।
भाई आप
वो
समझिए
T2
ना, रुकिए रुकिए, ये एक रॉड है, इस पे एक फोर्स यहां लग रही है, एक फोर्स यहां लग रही है, और एक फोर्स यहां लग रही है, ये है ना, ये फोर्सेस है, ये फोर्स है 2mg यहाँ इस पॉइंट के अबाउट, ये है mg, और ये है T1। ये डिस्टेंस है L/4, ये डिस्टेंस है L/2, और ये पूरा डिस्टेंस है L। नाउ प्लीज टेल मी, ये जो 2mg फोर्स है ये इस पॉइंट के अबाउट P के अबाउट रॉड को यूं घुमाएगी या नहीं, ऐसे, यस और नो,
हाँ
टर्निंग इफेक्ट ऐसे है ना,
यस।
तो ये एंटी क्लॉकवाइज है, एंटी क्लॉकवाइज। मैं अलग अलग कलर से लेता हूं, ये हो गया 2mg की जगह एंटी क्लॉकवाइज। 2mg का जो टॉर्क है वो मैंने लिख दिया 2mg फोर्स इनटू व्हाट इज द परपेंडिकुलर डिस्टेंस L/4 इनटू L/4, और मैंने बोल दिया वो एंटी क्लॉकवाइज को मैंने पॉजिटिव ले लिया इसलिए प्लस, ठीक है। नाउ अब टॉर्क ड्यू टू mg बताओ मुझे, टॉर्क ड्यू टू mg बताइए, ये mg फोर्स है, इसका रोटेशन कैसे घुमाने की कोशिश करेगा रॉड को, एंटी
एंटी
क्लॉकवाइज, यस और
क्लॉकवाइज।
नो, एंटी क्लॉकवाइज ही घुमा रहा है ना, हाँ,
हाँ
एंटी क्लॉकवाइज। सो mg इनटू लेंथ, परपेंडिकुलर डिस्टेंस कितना है, आर्म लेंथ L/2, और उसको भी मैंने पॉजिटिव लिख दिया, क्यों, क्योंकि वो भी एंटी क्लॉकवाइज है। अब देखिए, अब ये जो रॉड है इस पॉइंट के अबाउट टेंशन किधर घुमा रहा है इसे, क्लॉकवाइज, ये ऊपर उठा रहा है भाई, यूं यूं, रॉड अगर ऐसे रखी है तो ये ऊपर ले जा रहा है इसे, क्लॉकवाइज घुमा रहा है, क्लॉकवाइज को मैंने माइनस लिख दिया, ये
नहीं
दोनों
पर
इसे एंटी क्लॉकवाइज घुमा रहा है। हाँ,
मेरा मेरा T2 के बारे में क्वेश्चन है, हाउ इज T2 इंटू 0 पॉजिटिव? वो भी ऊपर लग रहा है ना।
सर सर आई हैव अ क्वेश्चन दैट हमेशा एंटी क्लॉकवाइज ही पॉजिटिव रहता है कि हम ले सकते हैं कुछ भी क्लॉकवाइज ही
कन्वेंशन ये
पॉजिटिव?
है कि एंटी क्लॉकवाइज को पॉजिटिव लेते हैं, बट इवन इफ यू स्पेसिफाई क्लियरली कि हमने क्लॉकवाइज पॉजिटिव लिया तो एंटी क्लॉकवाइज को नेगेटिव ले सकते हैं। फॉर एग्जांपल जो हमने वेक्टर्स में किया था कि हम अपवर्ड डायरेक्शन को पॉजिटिव लेंगे, तो हम डाउनवर्ड वाले वेक्टर्स नेगेटिव ले रहे थे, लेकिन मैंने आपको दिखाया कि अपवर्ड नेगेटिव ले लो तो डाउनवर्ड को पॉजिटिव लेके सेम इक्वेशन आ रही है। सिमिलरली हियर, सो इट वोंट मेक एनी डिफरेंस एट ऑल।
अच्छा तो सर T2 0 आपने ऐसे ही लिखा है क्योंकि उसका मैग्नीट्यूड 0 है तो कोई डायरेक्शन लगाने का फायदा नहीं है।
बोल रहे हैं बेटा,
वो जो T2 0 लिखा है आपने, वो उसमें साइन वो एंटी क्लॉकवाइज या क्लॉकवाइज का नहीं डाले क्योंकि वैसे मैग्नीट्यूड 0 है ना, तो
हाँ, तो उसके लिए साइन की जरूरत ही नहीं है ना, इसलिए मैंने प्लस
हाँ।
माइनस नहीं लिखा, बिकॉज
अच्छा
जीरो है।
Sir, we can't use the point number 3 as our reference point, right? Because
वी
we
कैन
get
वी
both.
कैन यूज एनी पॉइंट, 1 मिनट,
But in
We,
that case, we'll get T1 and T2. So
हाँ
there are
तो
three.
we will solve
Sir,
them.
but
We will solve.
instead of doing it about one point and then taking the to overall torque, getting the other tension, I did both the tensions separately. Like torque
Please
about
pay
C and then torque
attention.
about.
Please pay attention. One child said, can I take, I'm very happy that you people are thinking. You can take it about this also. Instead of P, I could have chosen C, center of mass, as the point about which I wanted to take torque. So in that case, you would have got T2 also, T1 also. I agree. But that would have been one equation, this, and another equation for torque. I have two equations and I have two unknowns only. T1 and T2 are the only two unknowns. So two equations, two unknowns, we'll be able to solve them. What is the problem?
Yes,
Here, if
write
you
it
choose,
separately for both the points P and Q.
बच्चों मैं आपको लिख के ही दिखा देता हूँ, ये लो भाई, आप लोगों को थोड़ा सा क्विकली कर देता हूँ. ये T2, ये T1,
सर मैंने
ये
सेंटर ऑफ मास से कुछ लिया ही नहीं था, तो एक
mg.
P पॉइंट से क्यों
एक मिनट, आप क्या कहना चाह रहे हैं, फिर से रिपीट करिए.
सर मैंने एक P पे टॉर्क का इक्वेशन बनाया और एक Q से किया और उससे दो वैल्यू आ गया, सेंटर ऑफ मास से
किसी
कुछ
से भी
लिया.
निकालो यार, it is going to give you the same answer. Please understand. You can take torque about this point. You can take torque about this point. You can take torque about this point, or any point on the rod. When the rod is in equilibrium, every point is in equilibrium. So the net torque, it will not rotate about any axis. So आप किसी भी axis के about torque लीजिए, you will still get the same answer. Are you getting it? So if I want to write the torque, अच्छा एक तो ये समझ में आ रहा है, अगर मैं इस पॉइंट के अबाउट लूं, चलिए मैं क्विकली करके दिखाता हूं. सेंटर ऑफ मास C, I will write the equation. Net torque about C due to this T2 will be clockwise or anti-clockwise. Everyone should speak quick.
Anti-clockwise.
Anti-clockwise.
Anti-clockwise, perfect. So T2 into L by 2, एंटी क्लॉकवाइज को पॉजिटिव ले लिया हमने, ठीक है. नाउ टॉर्क अबाउट C ड्यू टू दिस विल बी इन क्लॉकवाइज और एंटी क्लॉकवाइज डायरेक्शन. क्लॉकवाइज. क्लॉकवाइज हैज टू बी नेगेटिव, है ना.
Yes.
अगर हमने एंटी क्लॉकवाइज को पॉजिटिव लिया तो क्लॉकवाइज को नेगेटिव लेता है. सो क्लॉकवाइज 2mg इनटू आर्म लेंथ, क्विक,
L by 2.
L by 4.
4.
Yes. Now, what will be the torque of mg about this point? Quick. I want everyone to answer.
0.
Zero.
Lovely, lovely. And what is the torque of T1 about this point? Quick.
Minus T1 L by 2.
Plus T1 L by 2.
हमने लिया है एंटी क्लॉकवाइज पॉजिटिव, सो दिस इज गोइंग टू बी क्लॉकवाइज. Clockwise.
Minus T1 L by 2.
Yes, खत्म. Is equal to 0. This is the
Sir,
torque
we
equation.
can cancel LL.
Whatever you do, वो तो हो ही जाएगा. सॉल्व करना अलग कहानी है, इक्वेशन करेक्ट लिखनी आ जानी चाहिए, ये इंपॉर्टेंट है. दिस इज, हमने क्या किया, नेट टॉर्क इज इक्वल टू 0 कर दिया बिकॉज देयर इज इक्विलिब्रियम. नेट टॉर्क अबाउट C हमने यहां पे लिया है अबाउट सेंटर ऑफ मास. एंड नेट फोर्स T1 ऊपर है, T2 ऊपर है, शुड बी इक्वल टू 3mg. ये दोनों नीचे हैं. Net force should be 0, net torque should be 0, equilibrium. This is called static equilibrium. यहाँ पे बॉडी रेस्ट में है. Net force 0, net torque 0. इनफैक्ट नीट का जो एग्जाम अभी आया था, जो अभी हुआ है, जिसमें बोल रहे थे बहुत टफ है, आई कैन गिव यू अ क्वेश्चन फ्रॉम देयर एंड यू विल बी एबल टू डू इट. कुछ टफ नहीं है, कॉन्सेप्ट क्लियर होना चाहिए. टॉर्क निकालनी ही नहीं आती है और अटक जाता है. एंड आई एम क्वाइट हैप्पी. हाउ मेनी ऑफ यू अंडरस्टूड हाउ टू फाइंड द टॉर्क अबाउट अ पॉइंट? ये जो रॉड का क्वेश्चन किया है हमने, लेट मी सी द थम्स अप्स. आई वांट टू सी हाउ मेनी ऑफ यू अंडरस्टूड दिस टॉर्क, जो अभी हमने ये रॉड वाला क्वेश्चन किया है. ठीक है, नेक्स्ट क्लास में आगे देखेंगे. आई कैन सी मेजॉरिटी ऑफ यू आर आंसरिंग इट.
सर कैन यू
And-
प्लीज कंक्लूड द आंसर कि आंसर क्या है आने वाला है?
हाँ, आंसर आप सॉल्व कर लीजिए. लेट्स सॉल्व इट. T1 एंड T2 निकालना है, अगर मैं कर देता हूं आपके लिए. दैट्स इट. सो T2 by 2 minus
mg by 2.
mg by 2. L को मैं खा गया हूं. माइनस T1 by 2 इज इक्वल टू 0. सो 2 भी खा जाइए. तो आ गया आपका T2 माइनस T1 माइनस इज इक्वल टू mg. ये आ गया. करेक्ट.
अभी लीनियर
Add these
इक्वेशन
two.
से सॉल्व हो जाएगा.
Add these two, you will get T1 gets cancelled. 2T2
T2 is
is
equal to
equal
2
to
mg, T1 is
4
equal to
mg.
1 mg.
T2
So
is m. 2 mg.
T2 is equal to
2
2 mg.
mg.
lovely. And therefore this will come out to be mg. ये mg होगा, ये 2 mg होगा, क्योंकि नेट फोर्स हमें 3 mg चाहिए ऊपर भी. नेट फोर्स नीचे 3 mg है तो ऊपर भी 3 mg इक्विलिब्रियम के लिए. सो वी गॉट द आंसर्स. ये 2 mg, ये 1 mg. हाउ मेनी ऑफ यू गॉट दीज आंसर्स? आई एम इंटरेस्टेड इन सीइंग दैट. किस किस को आया T1 T2? करेक्ट. नाइस. शुभन, अद्वय, ऊपर दिखाइए किस किसने दिया था. ऊपर दिखाइए चैट में. यस. ओके. ठीक है. एनीवेज चिल्ड्रन, वी लर्न टॉर्क टुडे. Don't worry about it. We will do it in the next class also. And this is something which is very important topic. So force, torque. You got a little hang of it in the class. That is more than enough. In the next class, you will have full clarity. जैसे आप forces को deal करते हैं, वैसे ही आप free body diagram और torque को भी deal करना सीख जाएंगे. So after the next lecture, you will be thoroughly clear in both. चलिए, all the best. Good wishes. Take care.
Thank you, sir.
Take
सर
care.
एक डाउट
Thank you,
है.
sir.
Thank you, sir.
हाँ बच्चे पूछिए, जिसको डाउट है वो पूछ सकते हैं. प्लीज फील फ्री. पूछिए.
सर हमने वो नेगेटिव क्यों लिया 2mg/4?
ये वाला.
हाँ.
हाँ, हमने देखो जैसे वेक्टर्स में ना हम ये लेते थे कि भाई अगर एक कार इधर चल रही है तो हमने कहा कि इसकी वेलोसिटी है u इधर है 10 मीटर पर सेकेंड स्क्वायर सपोज 10 मीटर पर सेकेंड. और फिर मैंने कहा इसकी एक्सेलरेशन ऑपोजिट डायरेक्शन में है, वो है 5 मीटर पर सेकेंड स्क्वायर. तो हम एक को अगर पॉजिटिव लेंगे ये डायरेक्शन को, तो ऑपोजिट डायरेक्शन को नेगेटिव लेंगे. यस और नो? सेम वे फोर्सेस के लिए ये टेंशन अपवर्ड पॉजिटिवली, तो ये वाली भी पॉजिटिव. T1 प्लस T2, T1 प्लस T2 माइनस mg एंड 2 mg, ये दोनों माइनस लिखे गए. माइनस 3 mg इज इक्वल टू 0 किया हमने. माइनस 3 mg इज इक्वल टू 0. तभी तो ये इक्वेशन आई थी कि दिस इज इक्वल टू ये. नाउ ये नेगेटिव क्यों ली हमने? क्योंकि हमने अपवर्ड डायरेक्शन को पॉजिटिव लिया, तो एनी वेक्टर विच विल बी डाउनवर्ड्स वो नेगेटिव हो जाएगा. सो इसलिए माइनस 3 mg. ऐसे ही रोटेशन में जो टॉर्क होती है ना, एक टॉर्क होती है क्लॉकवाइज, एक टॉर्क होती है एंटी क्लॉकवाइज. नाउ if suppose I am finding torque about this point, so this force, T2 force, is going to rotate it in which direction? Suppose ये rod है, T2 force ऊपर लग रही है, तो ये इसे किधर रोटेट करने की कोशिश कर रही है?
एंटी
एंटी
क्लॉकवाइज.
एंटी क्लॉकवाइज को हमने प्लस लिख दिया कि भाई एंटी क्लॉकवाइज को हम प्लस लिख रहे हैं उसकी टॉर्क को. तो हमने क्लॉकवाइज डायरेक्शन को क्या चूज कर लिया? नेगेटिव. अब हमने देखा इसकी वजह से टॉर्क जब निकालने चले 2 mg की वजह से, तो वी फाउंड ये कैसे रोटेट कर रही है इसको. क्विकली बताइए. क्लॉकवाइज. अब एंटी क्लॉकवाइज अगर पॉजिटिव लिखा है तो क्लॉकवाइज को क्या लिखना है हमें? नेगेटिव. फिर हमने देखा mg की तो टॉर्क 0 ही है. फिर हमने देखा इसको T1 को कि T1 की देखता है. T1 कैसे रोटेट कर रहा है इसको इस पॉइंट के अबाउट? यूं यूं ऊपर जा रही है ये फोर्स, यूं टॉर्क. सो दैट इज क्लॉकवाइज. क्लॉकवाइज है तो माइनस, क्लॉकवाइज माइनस, क्लॉकवाइज माइनस, एंटी क्लॉकवाइज प्लस. ये डायरेक्शन चूज की हमने. गॉट इट?
यस सर. थैंक
Good.
यू सर.
क्या बच्चों, ऑल द बेस्ट. थैंक यू फॉर हैविंग ऑल द पेशेंस to learn such a complicated topic for a 10th class student, and all the best. Good wishes. Take care. Good night.
Thank you, sir.
Thank you.